How's it going today, ladies and gentlemen? So today we are looking at Lewis Dot Structures. So right when we start off, we have our definition for valence electrons. The definition is valence electrons are the electrons that are in the highest energy level. I've highlighted a couple other important facts. So the first thing is valence electrons are the farthest away from the nucleus out of any other electrons. Valence electrons are always in the highest energy level, and then valence electrons are the electrons that are involved in chemical reactions and bonding. That's why they're so important. One of the things that I want to stress is that it repeats itself. It repeats itself that valence electrons are the electrons with the highest energy level. So I will explain to you what that means using the example thallium. So thallium is number 81 on the periodic table. Remember, we assume it's an atom unless otherwise specified, so we know that it also has 81 electrons as well as 81 protons. We also know that valence electrons are in the highest energy level. The highest energy level is 6. You have to remember that the numbers in front tell us the energy level. So we notice that 6 is the largest number, so that's the highest energy level. It's important to note that thallium only has 3 valence electrons. We do the 2 from the 6s sublevel plus 1 from the 6p sublevel to equal 3. It's important to note that even though the 4f and the 5d fall in between 6s and 6p, that they are not considered valence electrons. They're only there because they have increased energy because of how many electrons they are holding. So now, using that information about valence electrons and what you know from the electron configuration Chemquest, you guys should be able to answer questions 1 through 4. So pause the video while you work on those questions. So next we have some information on board diagrams. So these are all the board diagrams for the second period or row on the periodic table, elements 3 through 9. We use these board diagrams to answer questions 5, 6, and 7. When you answer 5, 6, and 7, you may have to think back to an electron's address. Electron's address is where you'll find information about the energy levels, sublevels, and orbitals. Remember that each orbital can only hold 2 electrons. So if you remember everything else, you will not have to take out an electron's address to answer these questions. And then one of the other sections, I think this is the last section. Yeah, the last section is electron dot diagrams. So in figure 2, we have examples of Lewis structures or electron dot diagrams for the atoms 3 through 10. So this is your entire second period on the periodic table. The first thing that's worth noting is that the position of the dots is important. If we are looking right here, we notice that the first dot goes on the right, second dot on the top, third dot on the left, fourth dot on the bottom, fifth on the right, sixth on the top, seventh on the left, and eighth on the bottom. So if we think about this, we can think about a generic element X. The first dot goes here, second dot, third dot, fourth dot. Then we just repeat ourselves. Fifth dot, sixth dot, seventh dot, and eighth dot. So in other words, you can think about it, you go around counterclockwise twice, putting 1 dot on each side. The maximum you have is 8. So now, using this information, we can compare Lewis dot structures to valence electrons. Remember, earlier in the packet, you figured out how to find valence electrons. You can find valence electrons by drawing the electron configuration and then looking at how many are in the highest energy level. So that will help you with 8 and 9. Number 10. Number 10 and the rest of the packet, something interesting happens. We start to see that elements of the same column, also known as group, have the same number of valence electrons. So what that tells us, if an element is in the same column as any of these right here, they are going to have the same Lewis structure. The only thing that's going to change is the element. The number of valence electrons they have will be the same, and the position will be the same, because remember, the position is important. So knowing this, you guys should be able to complete the rest of the packet, questions 10 through 18. Make sure you finish this, come to next class with any questions that you have, and we'll take it from there.